done a little bit of this back in algebra too. We spent time in algebra 2 dealing with a lot of quadratics, some cubic functions, we graphs and things like that. We factored stuff like that. We talked about how do you get an idea of graphing a cubic, how it comes up and increasing. Then we did the dance moves where it's going the other direction. All of this, if you're positive, your tails are this, negative, your tails are going that way. We talked about what was called end behavior. End behavior is what was happening at the very ends of the graphs. And we talked about as x is increasing, what is f of x doing? As x is decreasing, what is f of x doing? Things like that. So it's kind of like a little refresher on that today. But as we get into this tomorrow and Wednesday, we're actually going to be able to do some pretty basic calculations to figure out what's happening in between the middle of graphs by the couple of tests that they have in the book here. It really isn't all that complicated. It just looks kind of weird. So let's talk about polynomials. Polynomials are going to be continuous in curves. What that means is that there are no breaks. There aren't going to be anything that looks like this if you're graphing, let's say with first quadrant, say it's coming down and you get an open spot and then it jumps here and does this. You won't have any of that. You won't have those piecewise functions. Those aren't continuous. You're not going to have an absolute value graph because it's not a curve. You're not going to have lines because it's not a curve. Everything's going to be an exponent with a degree greater than 1. Very, very straightforward. We also know that these are going to be called power functions. What happens here is there's two things. There's basically going to be two styles of graphs. If f of x equals x to the n, where n is an even number, the graph is going to be symmetrical about the y-axis. If that it's odd, it's just symmetrical about the origin, which means if it's x to the n and n it looks kind of like that-ish. Here's your y-axis. And if this is, this over here. And x to the n, if n is odd, it'll look like this. Okay. Obviously, there's going to be a lot of subtle changes to that, but if it's just straightforward x to the n, so if it's x to the third, x to the fifth, x to the 11th, they're all going to kind of look just like that. There's going to be slight variations in how fast they're going to tail. Obviously, the exponent's going to tail quicker, but they're all going to go through -1, -1, 0, 0, and 1, 1. Every single one of them will. Same deal with x squared. If it's x squared, or x with an even power, they're all going to go through 0, 0, 1, 1. Oh, sorry, 1, 1's on this side. 1, 1, and -1 and 1. If it's an even power. It's just how fast is it tailing up because the exponent gets greater, or if it's smaller, it's going to tail out slower. That's it. Okay? There's no other middle term in this case. We're just talking about x to the n. That's it. Okay. Hopefully it's not bad. I think you probably saw that last year, but you probably didn't call it a power function, right? What?
We're just talking about
And how you look like Shaggy.
I get over it though.
From Scooby-Doo.
Like I just said, notice there are two different curves here on the left. You don't have to write this up, but I just mentioned that if your exponent is greater, the exponent is larger, it's still got to go through 0, 0, 1, 1, and 1, -1 and 1 for any even value. Those 3 points are all going to go through. It's just how fast is it rising and how fast does it kind of bottom itself out. It doesn't look as curvy, if you will, as the regular x squared one. Same deal with the odd function, or not the odd function, but the odd exponent one. Every single one of them is, no matter what, is still going to go through -1, -1, 0, 0, and 1, 1. They all have to because it's just how math works. It's just how fast they're tailing. That's it. So what we're going to be able to do here is sketch these with respect to a shift. Okay? We'll be able to sketch these with some respect to a shift. This was due earlier, so I'm not taking that, just so you know. So if I want to sketch negative, f of x equals negative x to the fifth, well, is it going to be increasing going from right to left, or is it going to be decreasing going from right to left? Yeah, you guys remember the dance moves? You know what I'm talking about that, right?
No. Yeah.
No?
No, you're
Yeah.
going to do it.
All right, so this is x squared, right?
Yeah.
This is negative x squared.
Yep.
X cubed?
Yep.
No, x cubed,
Yep.
negative x cubed.
Yep.
Sine.
See,
That was
negative.
Play dance.
He doesn't look like
Actually, I used to have the dance moves.
Well, it could be an emphasis like that.
That'd make more sense if we did it.
No, because you're finding it M.
It's an odd exponent, so it's going to mirror the same thing as a cubic function. But yet, what direction is it having to go?
Down.
It's moving down from left to right. It would look something like that. Okay. If I look at the other one, I have x plus 1 in parentheses to the fourth power. It's an even exponent, but what is it doing?
shifting.
It's which way?
Left.
Is it going left or is it going right?
Right. Right. No,
It's
left.
going by what?
Wow.
Well, think about it. If it was just x to the fourth, if it was just x to the fourth, it'd be something like that, right? Where x, you'd have your points at 0, 0, 1 and 1, negative 1 and 1. So if I'm adding 1 to each of those values of x, 5. Thanks. So, okay. Awesome. Which way does it have to go?
To the left.
I say. Is it going left or is it going right?
Why are you
You
making
got a
us
50-50
like
chance.
left?
If it's going to the left, well, think about this here. You've got 0, 0, 1, 1, negative 1, and 1. This is your value of x. So I add 1, and it moved over 1. I add 1, and it moved over 1. I add 1, it moved over 1.
But it makes sense.
No.
I think we're thinking of the.
You're thinking your h's and k's, right?
Oh, it's not the
Yeah.
same thing?
That's what I was.
Wow.
That's why.
Don't do this.
Dang it.
I thought I
You
knew what I
got
was
me.
talking about.
No, when I see one calculator, it goes the other way.
Did it?
Yes.
Well, let's look at the coefficients then. Let's figure it out the other way then.
What?
If you guys remember last year, this is, I don't want you to write any of this out. I don't want you to write this stuff out. What I want you guys to remember from last year is that we did this whole polynomial stuff as f of x was just some awful looking statement. It was an awful looking statement. What I want you to think of is descending order. Remember what descending order was? Start at the highest exponent and work your way down. That's your standard stuff. You put things in a descending order, so you have your highest power up front and work your way down. If you skip a power, is that okay? Absolutely, it just means there isn't one there. So when you're looking at polynomials, we're going to look at them in terms of a descending order because that's how you're going to be able to identify what's happening with the graphs on the tails. What I mean by the tails is on the ends. Okay, what's happening on the tail ends. So, well, I'll go back to it. I want to show the tails first and we'll come back. Okay, no worries. So what I want to look at here is just a regular, boring f of x is x squared. Regular boring f of x is x squared. We all agree that it is the value of a, the leading coefficient, is positive, right? We know from all the times if it's positive x squared, it's just a parabola and it's up like a cup, right? It looked like that. What's happening as x approaches positive infinity? Oops. What is f of x doing? Where is that going? Which one is the f of x value? Is it the x's or y's? It's the y values. So as x is getting bigger, what's happening to f of x? So what's it approaching? Positive infinity. What we hated about these is that the book wrote it backwards. They always say what as f of x is approaching positive infinity, your x value is approaching positive infinity. To us, that didn't make any sense because we're so used to in terms of ordered pairs. X generates the y. It's easier to say it backwards. Pre-calc book does the same thing. They give it to you guys in terms of the y value, the f of x value first, and then the y, the x. I hate having it reversed. What I want you guys to think of is what's happening to it as x gets larger. What does f of x do? Going the other way. As x is getting smaller, what does f of x do? F of x is? It's getting bigger. Remember, the f of x is the tails. What is going on in the graph? As you're moving left, the graph is going up. As you're moving right, the graph is pointing up. Okay. Now, this holds true if this was also a 4, or a 40, or a 408, because all of those exponents are what? You're all even. Okay. So what we're able to do here is if we start looking at just the tails, we can make up a kind of like a general rule. If f of x, I don't want to write this to make the most sense. If your a value, let's say, it's a to the x of n. All right. If a is greater than 0, positive. When I say a is greater than 0 or a is positive, what's easier to think of? Positive. Yeah, I think positive is better. A is positive.
So do you want to start?
Yeah, we're going to generalize some rules for the tails. These are like the rules of the tail rules. What's happening on the ends. If a is positive and n is even, what are the tails doing? What would both the tails be doing? What direction would be? Which way? Up. The tails would have to be pointing up. There could be a lot of stuff going on in the middle. All we're looking at is the leading term coefficient. We always look at the first term coefficient for this. This is always. The first term will always let us get this. Well, what if a is negative and n is even? Now which way would it be pointing? Down. The tails will be pointing down. No matter what. It doesn't matter what's going on in between. But if the first term is, negative 6x to the 8th power, the tails of that graph will be pointing down.
So, what if it's even? Oh, wait, okay.
And then the other way, if A is positive and N is odd, what's it doing?
Other way. Oh, wait. No.
It's increasing, so one's pointing down, the other one's pointing up. And then obviously the other one's just the opposite. What your book does to describe all of this, it takes up a full page and it puts a lot of dotted lines and a lot of other letters and a lot of other words into it for something that is this basic. Okay? What they're trying to do is show you that in general, there are many different curves that can occur between, the first term and the last bit. I mean, if you've got a polynomial that has a 7th degree polynomial, could have up to 8 pieces to it. Remember, it goes 7, 6, 5, 4, 3, 2, 1, and then it could have a constant thrown in there. So there could be 8 parts to a 7th degree polynomial. There was always plus 1 more possible parts. Do you remember how many possible, I'm trying to think if you guys did this or not. Do you remember how many possible changes of directions there could be? Remember how you did that?
One less.
It was minus.
Yeah, n minus 1. Okay, so you have that many, you have up to that many changes of direction. Do you remember how many possible zeros you could have? If it's a 7th degree polynomial, how many zeros could you have? 7. You could have 7 of them and stuff like that. That's a lot of the stuff that we're going to be looking at over the course of the next couple of days. Kind of deals with just that kind of stuff. Right? There's not a lot of super crazy stuff. It's just the idea of what's going to happen when we get into the weirdness of the curves. So just real quick. These are going to be the type of things that we're going to ask you guys to do without calculators. Because obviously you could put this in a calculator and look at a tail and say, oh, I know which way it's going. True. But if I'm looking at just that first problem, f of x equals negative x cubed plus 4x, what are the tails doing?
They're going.
It's cubed.
It's going this way.
Yeah.
It's doing the John Travolta. Do I care what's happening in the middle?
No.
Will I be able to figure out what's happening in the middle? Yeah. Someday. Will I be able to find the zeros of that?
Yes.
What's the first rule to find zeros? Good work. So if I set this equal to 0, then what would I do? I factor, right? Well, first things first, what should I take out if I'm going to factor that? What if I take out negative x? Does that change anything? Because then I get x squared minus 4. What are the zeros of that function? Plus or minus 2 and 0. This one has 3 zeros at plus or minus 2 and 0. Now, notice I'm taking this a step further than what you really need to look at today. But knowing that it's a 3rd degree polynomial, you guys remembered from last year how many possible changes of direction can it have? It could have up to 2 of them. I know I have 3 zeros, and I know that my tail are doing this. So if I wanted to, which we will eventually, I could plot my zeros. And I know that my tail is going this way, so it has to come through here. It's got to change and come back down through here. So this graph has to look like that. Do I know what these 2 values are? No. Do I need? Yeah, but do you remember a thing called a relative max or relative min? I think we called them local max and mins, didn't we?
Yeah.
I think in the Algebra 2 book they called it a local max. you could figure these values out because there's going to be some change in direction here. Well, whether or not we use it on a table or we can calculate it, well, that's to be seen. But we get the idea that we can do that problem. All right. Not so much today, but just so you know where we're headed. But that's not terrible, is it? Okay. All right. Let's look at the other two then. If I'm looking at x to the fourth minus 5x squared plus 4, what are the tails doing there? They're both going up, right? Even power first term's positive, so the tails have to be pointing upward. So I know that this graph, well, it's convenient. Didn't mean to do it like that, but whatever. Can you factor that? Just wondering if it's an x to the fourth, x squared, then a constant. Do you remember how you do that?
You.
Minus 1
What
You
little
complete the square.
No. You can do it the exact same way as you would factor something else. If it was just x squared, x, and a 4, you could factor that. The reason that it works to factor the same way is because these two powers go down by half. No, this is just one of those things that works. So I can ask the question, what times what's positive 4 that adds together to get negative 5? So it'd be negative 4, negative 1. So this would be x squared minus 1, x squared minus 4. If I FOILed that out, I get x to the 4th minus x squared minus 4x squared plus 4. Yeah. So how many possible zeros could I have? 4 of them. What are my 4 zeros? Plus minus 1, plus minus 4. Oh, thank you. And if we wanted to get real fancy, I know the tails are going up. I have 0 here, 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 which means it has to go zoom, 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 zoom. It has to look something like that. Just because the rules that you guys recalled from last year. What's that?
Yeah.
Yeah, the line intercept would be 4. Yeah, well, that's really good. I didn't even think of that. You're right. Yeah, that'd have to be a 4. Okay. All right. Last one. Oh, did I cut that off by mistake? Was it just minus an x? Okay. On the last one, we have x to the 5th minus x. So you have x to the 5th minus x. That means it's increasing from left to right. Tail up, tail down. Come on. There we go. So we're having so much fun finding zeros, we might as well do another one. What's your first rule of factoring? What's set it equal? Okay, after we set it equal to 0, what's the next one? What's a GCF? All right, so you have x and you have an x to the 4th minus 1. Is x to the 4th a perfect square? Yeah. Is 1 a perfect square? Is that a subtraction symbol? Yes. So that means you can do the following. X, and we have x squared minus 1, x squared plus 1. And I can only do what? You're right. Which one? The minus one. I can only factor this one further because you get x, you have x plus 1, x minus 1, and this is an imaginary root. I can't factor that any further. I have plus or minus I here, which we're not worried about. Yet, right. Now, oh, forgot to write that last bit. I don't think, I know we are going to talk about complex numbers. I don't remember if the pre-calc book graphs them or not. I think that's in 2+4. I. Imaginary.
Well, you got
Yeah.
two.
Yeah.
Well, I know we did the, you know, adding, subtracting, multiplying of the I stuff. I'm just saying, I'm wondering if they have you guys graph. They do not. Okay, cool. So yeah. Yeah, the multiplying complex and taking all that, the adding, subtracting, that stuff's very, very simple. So in this case here, we'd have, it looks something along those lines. Okay, because there's some other imaginary roots, something. We've done enough of this. The stuff that I'm looking at with tomorrow, because I will be in a meeting, unfortunately. I know, you guys are very sad. I have no idea.
That one girl.
One of the things, I honestly didn't think I was going to have time to get into it. It was kind of going through some of these zero things. Tonight, you guys are talking about what's going on with the tail stuff. Tomorrow, you're going to be finding the possible zeros. And in the book, they talk about where it says, find all the real zeros in the polynomial, determine the multiplicity of the zero, and the number of turning points the graph of the function has. Now, here's what that means. In this equation, how many possible zeros could there be? 5. So what I would do is say, we factored it. There are 5 possible. We found 3 of them, 0, 1, and negative 1. How many possible turning points could there be then? 4. You could have 4 turn points. Okay? When I found the zeros here, did it ask me to graph it? It did not. It said use your calculator, so you can kind of get the idea. To be honest with you, I would like you guys to start to get the rough sketch of some of these, just by looking at your tails, what the tails are doing. When you find and factor out a 0, you kind of get to that. I did want to show you an example of one of the factor ones that I think you might have forgotten. Let me put this up here real quick. If I wanted to factor and do this whole thing of this one here, f of x is x cubed minus 4x squared minus 25x plus 100. What I'm going to do here is kind of walk through what the day 2 part of this stuff, the assignment part's going to ask you. It's going to ask you to find the zeros and talk about turning points and all that kind of stuff. Do you guys remember the trick when you saw 4 terms that were in descending order? Group them. Yeah, very good. You guys remember that grouping?
Yes.
Grouping was one of the more simplistic ways of factoring, especially if you had 4 terms and you were descending, you had all the degrees. When you group them, you're just looking for GCFs. When my 3rd term is negative, do you remember what you would do? No, do this. Because it's kind of the same idea, Colton, but by doing that, it forces you to remember to factor out the negative of that 4th term. It's just it's a little thing that I do just because I used to be awful with remembering signs, and it's just a little trick. So what's the GCF of x cubed and 4x squared?
X squared.
X squared. So I take out the x squared, and I'm left with x minus 4. The next one I have to take out the negative, well, it's pretty simple. What's going to be? 25. Are these 2 in parentheses the same?
Yes.
Good. They should be. If they are, you write it down. And then what are you left with?
And then you get x minus 1.
Good. Now, could I have skipped that step and wrote right away to the plus minus 5? Yeah. So your zeros for this function would have been 4 and plus or minus 5. How many possible changes of directions did it have?
3.
It was a 3rd degree, so how many
Oh,
changes?
two.
It'd have 2 changes of directions. 2 possible turns. And then these were my zeros, and I have 2 possible turns. What I think of that, I'm trying to think if there's any other.
I actually like it.
Thank you. There's a part in there that talks about what's called multiplicity. Multiplicity means, is it a repeated 0? Do you remember what a repeated 0 would look like on a graph? let's say you have this, x squared plus 4x plus 4. And I'm going to find the zeros. What times what's 4 again? Did 4? 2 and 4?
I just have 2.
Oh, I thought you said 2 and 4, I'm sorry.
No, just 2.
So x plus 2, x plus 2. Isn't that a repeated zero?
Yes.
So the multiplicity means, is it a repeated zero? Okay. So in this case, there is a repeated zero, and where's that repeated zero at?
2. Negative 2.
That means it just touches the x-axis once. It would be something like that. Okay. I know you've seen that. You just never heard of it in terms of a multiplicity. It just means repeated zero. Okay. When I was going through the problems in here, what I had on the day 1 was right. 9 through 11, 15 through 21, all of that's just some odds. The day 2 stuff, I want to change it up. Yeah, because you've got enough. Day 2 stuff is just a real
So what are
fast
we doing
factor.
tomorrow?
You're going to be working on that in class.
Oh, so we're doing day 2 instead? Oh.
We're doing the second part of that.
So the day 1 is the 9 through 11, and then 15 through 21 odds. 9 and 11, there's a couple of parts to them. It's just talking about the graphs. The day 2, I want you to change it to 27 through 42 all. Okay. And then the day 3, as of right now, it looks like it's still going to be the exact same stuff. What we're going to do with that, it's on that sheet there. It's still, we're going to start talking about writing the polynomials going backwards. Yeah, it's just kind of working backwards. And you guys actually have done that before. For example, if you knew you had a 0, if your zeros were at -3 and 6, if your zeros were -3 and 6, what were your terms?
X plus 3, X minus 6.
Very good. There'd be x plus 3, x minus 6, and then you could FOIL it out and write the equation, right? What if I actually gave you 2 different versions of it?
Well, then I'd be lost.
You point slow.
Nah.
What do you mean different version?
The intercept.
If these are my zeros, when this one would be, tails would be up, right?
Yeah.
Because if you could give me another equation besides just that gave me tails up. Because this is the way we did it last year. Very fast. You got x squared minus 3x minus 18.
Yeah.
What if you did this?
Yeah, you just put the minus.
And then you get negative x squared plus 3x plus 18. Wouldn't it be the same zeros? Just going the other direction? It would be backwards. See what I'm saying? So you can change that by just changing that value of a. And we'll talk more about that, then would be Wednesday. That wouldn't take very long. Thursday then would be synthetic division.
Oh, I
Love
love that.
synthetic division.
I don't remember how to do it, but I know I like it.
Synthetic division is awesome.
We did it last year.
You
It was really
divide
easy.
by the zero, just go through. Synthetic division, that was this stuff.
Is that where you line it up in like an L or something like that?
Yep.
Yeah. That was
That sounds good.
time consuming.
And you want to divide that by.
It's not hard, it just takes a little while.
So if you had to use synthetic division on that, remember you just pulled out all your coefficients. 3, -17, 15, and 25. And then you divided it by the 0 of that. What's the 0 of x minus 3?
I believe that's 5.
Or x minus 5. Divide by 5. Remember, drop it, multiply, add, multiply, add, multiply.
And then you can start all over again.
Well, no, this is just one time. You're not factoring that way. I love factoring this way. Factoring that way is so fast, except when you remember we had to do your plus minuses and go through all that. And some of those ones I gave you guys, man, those are awful.
Yeah, they were.
So this meant you had x minus 5, then it would have been 3x squared minus 2x minus 5.
You need to do it again.
You could go again. So what was it? Factors of 3, factors of 5 divided by factors of 3 to start going through it. See, I can go further. So this one isn't bad. I mean, it's just negative 15 to 2, so that would be 5 and 3. So you know 3's going to happen. But we'll worry about more of that. I know you guys did this.
Calculator.
Sometimes you won't get it. I know that we've done that. We should be able to get through most of that. I don't. Now that I keep saying this out loud, since I'm not around tomorrow, we might not be quizzing this week. Then we might have to wait till next week, which is fine.
no.
Please don't.
Yeah, no further
that's-
Monday, that's just.
I should already have one for next Monday. I mean, what we can do is just add complex numbers into it and just have just a little bit longer of a quiz than we normally do. Because it just works the same. It's not a big deal. So we do that for Thursday, Friday, because I want to do long division, which you guys hate. Synthetic's easy, but then we can do what they're doing with their imaginary numbers is very, very simple stuff. So we'll probably do it for Tuesday. I think it'll probably work out well. Give us some time. They'll probably look punishing for that. So you guys know where we're at. Because then next week I think we have a half day on a Friday, if I'm not mistaken.
What?
For Halloween.
No, it's for the conference prep time.
For Halloween.
No, it's for the conference prep time.
Mr. Murphy, what are you going to be for Halloween?
Mr. Murphy.